You a little bit about debugging in JavaScript right now. And while I talk about debugging generally, I'd like you to get started by typing in this code. Remember, you can get a little template for HTML up by just doing the exclamation point and then hitting return. And then I've added in this little script block right here. All right, so while you're doing that, let me just talk about debugging generally. It seems like as a developer, professional developer, most of our time gets spent just fixing our own syntax errors. Really, there's three different big categories of errors that you make while you're programming. One of them is a syntax error, and with syntax errors, that's typically something like you misspelled this. Like, so maybe I declared S manager here, the string to hold manager, and then later on, if I were to go and use it, maybe I do S manager, and I don't even notice that it's a different word. So capitalization is one example of how we can mess things up with syntax. Or in a lot of programming languages, you leave a semicolon off and suddenly everything is not working. So there's that. And then there's also other types of punctuation that can mess you up. If you're dealing with if statements and things like that, you can have, there's single equal signs, there's double equal signs, there's triple equal signs, and sometimes you use the wrong thing in the wrong place and you get unexpected results. So punctuation is something that you always have to watch out for when you're doing programming, and that's syntax. And commonly, if you make a mistake and you're using an editor like this, you see this gets a squiggly underline there. So if you're using not just a text editor, but an actual code editor, it usually tells you that you're about to do something that's going to break, and that's a handy thing. So syntax errors can oftentimes be picked up by a code editor. But there are other types of errors that it can't figure out. So one of those would be a logical error. So for example, I know that there's this function that gives me out the day of the week in the numbers 0 through 6. So you think it might be 1 through 7, but it's 0 through 6. And so if you did some if statements based on first checking the day of the week and then doing some logic, while syntactically everything might be correct, logically you might be saying Taco Tuesday on Wednesday, for example, in your code. So the computer doesn't know that you don't understand how the functions work or things like that. So logical errors can be your fault as a developer, and the computer can't fix that. And then lastly, there's runtime errors. So let's just say I had some function where I was multiplying two things. Let's just say I'll do inum1, and then I'll do times inum2. So if I had two integers that I was planning to multiply together, and maybe I was reading those in by doing something like inum1 equals prompt, and then we say enter in a number. Well, we know that doing this type of thing results in returning a string, and so potentially multiplying two things that are strings isn't going to give the correct result, or maybe this is empty, or maybe what if you did something like enter in a semicolon or some other weird syntax when you were supposed to enter in a number. So that's something that in normal testing you would probably not notice because you're just entering in numbers and you're like, hey, everything works. But then a user later on enters in something that wasn't expected and suddenly everything breaks. And so we would call that a runtime error. Some number was passed to a function or a statement that wasn't expected and it breaks everything. So anyway, so there's three different kinds of errors that might come up. Let's talk more about this situation right here. So yes, you could pass in a string when a number is expected. What are some other things that a user could do, maybe in a web form or as part of entering in this little prompt box? Like, what are some things that they could enter in that would be bad? Well, they could leave the string empty. They might paste in enough text to complete an entire book. They might enter in a 0. They could enter in a whole number when they need a decimal. They might enter in a decimal when you need a whole number. They might type in the right thing, but they might include some spaces in there. and also they could enter in weird characters. So there's all kinds of ways in production that a user might mess you up. So I'd like to demonstrate a couple of different things um, that relate to debugging. So we've already got this entered in right here. So here's my high-level idea. Our employers, or perhaps your intrepid instructor, commonly types things in and makes a lot of mistakes. They put things in mixed case, they add spaces when there's not supposed to be, etc. Now, typically we wouldn't be adding things in this way in a real fixed manner, but rather what could happen instead is if we had some input box on a web form or something like that, or a prompt box, as I or other people enter in the names of new employees of our donut company, we might accidentally make all kinds of inconsistencies that are errors in entering in that data. And of course here, these employees are being added to an array. This one's just a standalone name, and this one is an array of names. I think I'll use this standalone one right here for testing, and then I can later use this when I get my problem to be a little bit more advanced. Okay, so what I'm thinking here is I would like to be able to test for problems and correct them. So this involves two things. One is I'm going to write some functions that clean this up. So that's one way to solve input errors by users. But then I'm also going to show you the use of the debugger. Okay, so first thing I would like to do is as I look at the type of errors that are commonly made, is I would like to get rid of the extra spaces. So I know that there's a function called trim that I can use for that. But that's not the only problem I'm seeing here. So I'm going to write a function, and I'm going to call it clean string, and I'm going to pass in a string of type employee name. And whenever I call this function, one of the things I want to do is trim the string that gets passed in, meaning that's a special function that removes any spaces at the beginning or the end of a string. So if I do sEmployee equals sEmployee.trim, let's see if this works. So first I'll do alert sManager. Actually, this isn't gonna It's not going to be obvious that I'm fixing anything at this point, so I'll put little single quotes around it, so this will make things more obvious. Okay, and then I'm going to click on, oh, see, there's my little squigglies. I had a little syntax error there. I'll hit save, and then let's go live here. And I come over here, and we see it still has that space in there at the end that we don't like. All right, fair enough. So let's see what happens if we pass this through. I'll take this name. I'm going to pass it through my functions. So sManager equals clean string, and then I'm going to pass in that name. Now, right now, that's not going to work because I didn't return anything. So I'll say return. And so therefore, like a little black box, we pass something in and it sends something back out. And this is what gets passed back out. All right, so I'll hit save. And I reloaded it and ran it again, and I'm able to see that that space has been removed. So one of the things I wanted to happen in this function is working correctly. All right, and this would be a good opportunity to jump right in and demonstrate some of the debugging tools. So I'm going to right click on here and do inspect. I'm going to go over to sources. I'm going to click on this, and I'm looking at the JavaScript here, and I'm going to set something called a breakpoint. So I'm going to click right here, and then I'm going to reload the page. Okay, and what I'm able to do now is hover over any of the variables and see what their contents are. And over here on the right-hand side, or perhaps in a different place if your window's arranged a little differently. So if I move this around, you see some of the stuff jumps around a little bit. But we can see two variables, this array that's going to be set and this manager string name, which is also going to be set. They're both empty right now, but the page knows that they are going to be set at some point. So what I can do is I can either hit this button right here, which just says, hey, run this thing until the next breakpoint. I only have one breakpoint, which means it'll finish. Or this is a special one right here. This icon says step, and this means go one line of execution at a time as the computer would execute them. So I go step, and after completing that, notice that what was once undefined is now set to something. So this statement has been completed. Let's keep, and then right now the array is empty, or the array variable, and now it's going to start incrementally adding things to that array, and we can see that happening in the computer's memory. What's in position 0, what's in position 1, etc. Okay, and it skipped right over the function that's right there. It hasn't been used yet, but now it's about to be used. So let's watch what happens here. And notice that at present, the S manager still holds something with a space in it, and watch when it goes away. Step. Okay, now we just jumped into this function that we have created. So we're in here. We can see that we passed in this variable. So there's another variable in the page now called sEmployee_name that's different from this one. Both of them hold the same thing at this particular moment. We drop into here, and after we run that, then this variable is now without that space in there because it got trimmed, and now it's about to return that to this. This still holds Samantha with a space in it, but in a second that variable is going to be overwritten. So we overwrite it, and then the next step is going to be pulling up that alert box. All right, let's run this one a second time, and I'm going to click, 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 click. Okay, so there are some other things we can do here. So for example, this says step over the next function call. If I just did regular step, then we're going to jump right into this function. But if I do this, then we were saying, yeah, I don't really want to jump down that rabbit hole and see all the functionality on that. So just skip it, have it do whatever it's supposed to do as part of that operation, and then go to the next line. And so it did execute everything in there, and we didn't have to watch the gory details. Let me demonstrate another way of doing this. We're going to go step, 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 step. Okay, this time I'm going to let it go into the function again. And these all relate to the functions. So right now we're in a function, and we're saying step out of the current function. So imagine that this was one with a lot of lines, and we didn't really want to be in there. Well, what we could do is just say, hey, I'm out of here. I just realized I don't want to see any more of this. So I could say jump back out of this, and it jumps out of the function and goes to the next line. Okay, so continuing on to the next breakpoint, if we do multiple breakpoints, that's one of the things we could do. Stepping one line of code at a time, stepping in over functions, stepping out of functions that we're already in. These are all very helpful things for us. Let me demonstrate one other thing here. I've got some old stuff that is not currently being used, but let me go ahead and demonstrate that. We can add in additional watch variables. Now, that might not make sense initially. Right now we see that S manager is known to the computer, but it hasn't been set. But it isn't saying anything about this variable in here because it's part of this function. If there are certain variables that we want to watch over the course of our program, we can add it in right here. So I'll write in sEmployee_name and hit return. Okay, So that thing is empty right now, and let's just kind of step on through this program. Step, step, step. It's still not set to anything, but as soon as we go into that function, suddenly it has been set. So if you have a program with a whole bunch of variables, whether they're in functions or not, one thing that can be very helpful and handy is if we put those variables in a watch area and just watch specifically the variables that we care about to try and figure out in particular why something's going wrong, when something's going wrong. Okay, in terms of my overall program in which I'm going to be cleaning up some strings, I'm going to continue that in the next video.